Okay, and now we're back in tutorial 2. This time we're going to be solving some nonlinear systems. I have a system here because I have two different equations and I'm going to solve them simultaneously. It's nonlinear because the second one is a parabola. I see a quadratic term, and since I only see one quadratic term, this must be a parabola. So we've got a line intersecting a parabola. I need to either eliminate or substitute. I'm looking at the x's, and actually these aren't even the same terms. One is an x squared and one is an x. So I'm going to be hard pressed to try to eliminate these. I see the y's, and they're almost ready to eliminate, in fact. Since they're not opposite signs, of course, they do not cancel out. But I can change that real fast. What if I just make one of them a positive? So if I just multiply, I think I'm just going to choose to multiply the top equation. If I multiply the top equation by -1, each term, of course, then the middle term, which is the one that I'm really focused on, becomes a positive y, which would eliminate here. I'm going to rewrite the entire system here. I've got now -3x, positive y is equal to +2, and the bottom equation has not changed, so I'll just rewrite that right here. Okay, it looks like we're going to be good to go. If I add these two equations together, my y's go away, and these are not like terms, so I'm going to choose to put the quadratic term first, and then the linear term, and then that's all equal to, well, 2 plus 0 is 2. So it looks like we are with a quadratic equation, so the same steps as our prerequisite tutorial. Let's go ahead and subtract the 2 so that we have it all equal to 0. We must have the 0. And now we'll go ahead and factor. Well, there's only one option for the front, so that's kind of nice. It's 2x times 1x, and what's really nice is there's only one option for the back as well. So 2x times 1x, 1 times 2, that's what it has to be, so if it's going to factor, of course. So I'll put my parentheses here. I'm not going to forget my equals to 0. The front have to be 2x and 1x. And since the back has to be 1 and a 2, I know that the 2 cannot go here in the front because, again, that would make a GCF here. And since there is not a GCF to begin with, there cannot be a GCF in the middle of my factors. So if it is going to be the 1 and the 2, it has to be the 1 and the 2. Okay, now I do need to know about my signs. I'm gonna change my color. I do know that since it's multiplying to give a negative, that one of these has to be positive and one of these has to be negative. I'm gonna do some quick little, I'm pretty sure that this will be the negative and this will be the positive. Though I'm not sure, this really is just a guess, so I do need to check. The inner terms make x, the outer terms make -4x. When that adds together, I do get -3x, which is identical to what I needed, so I know that I have factored correctly. Now that I have my correct factors, I can go straight to my answers for x. X could be -1 divided by 2, so -1/2. Or x could be +2 over 1, which would just be +2. So these are the two values that x could be. So it looks like we have two solutions, two ordered pairs, which makes sense. If we have a parabola, let's just say that the parabola looks like this, and the line, let's just say that the line looks like this, of course we could have two solutions. I'm not suggesting that the graph has to look like that, but it could. Okay, so if we have two different x values, that means we need to substitute back into the original twice. So I'm going to come off to the side here and substitute in. Let's just start with the -1/2. And I think because of the quadratic, I'm going to choose the top equation. I know that 3x becomes 3 times -1/2 minus y. Well, let's just say for our notes, I'll keep it as 3x for right now. Okay, so 3x minus y is equal to -2. So that becomes 3 times -1/2 minus y is equal to -2. And this is -3/2 minus y is equal to -2. When I add 3/2 to both sides, I've got that -y equals, this is -4/2 plus 3/2 makes -1/2. And of course, I just need to multiply by -1. So it looks like I get y is +1/2. So one of my solutions is -1/2 comma +1/2. Sounds good. Let's also plug the 2 into our top equation. So again, we had 3x minus y is equal to -2. So now we've got 3 times 2 minus y is equal to -2. or rather 6 minus y is equal to negative 2. And if we subtract our 6, we'll have negative y equals negative 8. So of course positive y equals positive 8. Great. So we have our other solution, which is 2, 8. We have two solutions to this system, and we just found them by elimination and then of course substitution at the end. So there's our first example. Let's take a look at our second example. Our second example is this top conic section is a circle because I have both quadratic terms are squared and they both have the same coefficients. We might not have the prettiest radius, but that's fine. And the bottom one is also a parabola because we just have the one quadratic term. Okay, so I'm trying to eliminate. This time the y's are not the same terms. We got y squared and a y. So maybe I try to eliminate the x's. I really just need to multiply by a negative 1. I think I'm going to choose to multiply the bottom equation by negative 1 this time. I like to put a little parentheses underneath or next to each term so that I don't forget to multiply every term. And let's see what we've got. The top equation is the same, x squared plus y squared equals to 13. The bottom equation is now negative x squared positive y is equal to negative 7. So we are good to eliminate. Our x squared terms will cancel away. And again, these are not like terms, so I'll just write them side by side. I choose to put the quadratic term first, and over here I've got equal to 6. Lo and behold, we have another quadratic equation. Let's get it equal to 0 by subtracting 6. So y squared plus 1y minus 6 is equal to 0. Gotta see your 0. And now let's get into our, I choose by trial and error. If you've learned another method of factoring, then by all, and that works every single time, by all means, please do that and teach it to other people. I choose to do trial and error for trinomials. Okay, one option for the front, y times y. Couple options for the back, 1 times 6, 2 times 3. So I know that if it is indeed going to factor, it will factor into two sets of parentheses. And since I now know that the fronts have to both be y, we're good to go in the front. I need to choose if it's a 1 and a 6 or a 2 and a 3. This time it's a little bit simpler to choose that because since it's just 1y squared, it really is just these numbers that are going to combine to give this 1y. And I can see that 3 minus 2 is going to make that. So I'm going to choose the 2 and the 3. It might be a guess, but I'm pretty confident in our guess. We still have a negative, so I know that one of them has to be positive and one of them has to be negative. And since the middle term has to stay positive, I'm going to put the positive sign with the bigger number and the negative with the smaller. Let's just make sure that we're correct. This is a negative 2y, and this is a positive 3y, and that indeed adds up to positive 1y, which is what we needed, so we've got it correct. Okay, so I've got two numbers. Y this time could equal to 2. Y could equal to negative 3. So this time I found the y coordinate of my answers. We're halfway there. Now we need to plug the 2 and the negative 3 into one of the top equations individually. We'll do that one at a time. I think I'm going to choose the bottom equation to substitute into. So I've got my x squared minus y is equal to 7. So since I'm plugging 2 in for y, this becomes x squared minus 2 equals 7. So now I've got x squared equals, I'm going to add the 2 and make 9. This is another quadratic equation, but it's pretty simply solved by taking square roots. When you put a square root symbol onto your equation, you of course always remember the plus or minus, because there are two answers here, plus or minus 3. Okay, so we actually, we plugged in a y value and we actually got two different x values, which means that this is one of our answers, 3, 2, and this is another answer, negative 3, 2. Now some people choose to write it like this as two separate ones, or if you're fine writing plus or minus 3, comma 2, and understand that this is two answers right here, I'm fine with that. Let's plug the negative 3 in. We've got x squared minus y is equal to 7. So that means that x squared minus negative 3 is going to be 7. This, of course, is x squared plus 3 equals to 7. I'm going to subtract the 3, and hey, I get another perfect square. When I take the square root of this, I remember that I'm taking both positive and negative roots, so plus or minus 2. So my other answers would be plus or minus 2, comma, the negative 3 for the y coordinate. These are my 4 answers. And it makes sense that we could have 4 answers because, again, we were talking about a circle. Let's just draw a circle. Yikes. And a parabola. So maybe the parabola looks like this and goes through 4 different ordered pairs. So it could look like this. Now, again, I'm not suggesting that the graph has to look like that. It's just a quick sketch. Okay, we do have 2 more. Let's look at this one. Okay, now this looks like a pretty interesting system here. The first thing I see that I don't really like is that we have a denominator here. I actually want to get rid of this denominator right now. I'm going to choose to multiply each term by that denominator just to undo that denominator. I'm going to multiply everything by x. That's going to cancel out that denominator, and I'm going to, let's just rewrite the entire system actually. I'm going to write the top equation first, is x squared plus x plus y squared minus 3y plus 2 is equal to 0, and this new bottom equation will become x squared plus x plus the y squared minus y that comes down from the numerator equals to 0. Okay. So we're pretty close to having almost the opposite terms. We just need, I mean, these are almost ready to eliminate. These are, and these are. We could actually get rid of all of these terms at once if we simply just multiply this entire bottom equation by a negative 1. So I might just do that, multiply everything here by negative 1. Let's rewrite the system again. The top equation is x squared plus x plus y squared minus 3y plus 2 equals to 0. And now the opposite of the bottom equation is negative x squared minus x minus y squared plus y is equal to 0. And now when I eliminate, actually 3 terms eliminate, which is incredibly helpful. I get negative 2y plus 2 is equal to 0. When I subtract 2 and divide by negative 2, I get that y is equal to 1, which is great. So we have half of our answer. Now we do need to plug this 1 back into one of the original equations. I'm going to choose the top equation. I've got my x squared plus x plus y squared minus 3y plus 2 equal to 0, and what am I plugging in? I'm plugging a 1 in for y. So this is now x squared plus x plus 1 squared minus 3 times 1 plus 2 is equal to 0. What's great is that we only have one variable remaining. It's the x. So let's see what we've got. We've got x squared plus x plus 1 minus 3 plus 2 equal to 0. X squared plus x. I've got 1 minus 3 is negative 2, and negative 2 plus 2 is 0. Okay, so that all just cancels away, and this is all equal to 0. We're still left with the quadratic, but this is not a trinomial. So this is not going to be trial and error. I only do that for trinomials, try. This is a binomial, which means it has to be a special pattern. And I see that there's a GCF. GCF is one of the easiest things you can factor out. If there's a common factor in both the terms, I can factor that common factor, which in this case is x, out of both of these two terms, leaving an x still in the first term and the 1 that's always been in front of that x in the second term. Pretty fast way to factor, and it actually gives me my two answers pretty fast. X could be 0, x could be negative 1. So we do have, again, it's weird. We thought we were just going to have one answer because we got one value for y, but when you plug that y into the equation, 2 answers branch off from it. So that means that there are 2 ordered pairs, 0, 1, and negative 1, 1. So we did actually get 2 answers to this one. So it looked like it was going to be kind of a gross problem here, but it wasn't because we were lucky enough to get a bunch of terms to cancel away. One more problem. We've got this one. Okay, and this one is actually the first example that we're not going to be able to eliminate. We have this awkward xy term, and I don't see any xy terms up in the top, so elimination is really not going to be the way to go. We're going to substitute here. I'm going to choose to substitute. I could substitute for x or for y. I'm going to choose to solve this bottom equation for y. To do that, I would need to divide by x. I know we don't usually divide by our variable, but sometimes we just have to. So I do know that y is equal to 4x. And if y is equal to 4x, then I can plug that, excuse me, not 4x, 4 divided by x. If y is equal to 4 divided by x, I can plug that right in here for this y, and there's my substitution. So I do have 2x squared now plus the y squared, which is 4 divided by x squared, is equal to 18. Let's see what this gives us. We've got our 2x squared. Now we've got 16 divided by x squared, and that's equal to 18. Again, I don't like that we have a denominator, so I'm going to choose to multiply every term by that denominator so the denominator can cancel away. So I'm going to multiply everything by x squared. That'll go away. Now I'll have 2x to the fourth plus 16 is equal to 18x squared. So we don't actually have a quadratic equation because we actually have a quartic equation, but it's going to be very similar. It will follow a quadratic pattern. We're still going to get equal to 0. So let's subtract our 18x squared because we are indeed going to factor this. I'm going to put that right in the middle since that's where it would go. I've got 2x to the fourth minus 18x squared plus 16 is all equal to 0. And as I said those numbers, something occurred to me. They're all even. I could just divide everything in half just to make my numbers a little bit easier. So I'm going to do that. 1x to the fourth minus 9x squared plus 8 is equal to 0. Okay, I'm going to factor now. There's only one, well, I know there's a couple options, but in order to get the same two things to multiply to give x to the fourth, it would have to be x squared times x squared, identical things. Here I've got 1 times 8, and I've got 2 times 4. So when I'm going to factor this, I'm going to put my parentheses here. I'm going to put the x squareds in the front because that's what's going to happen there. I do need a 1. Again, this is easier because we got the leading coefficient of 1. So it's really just what numbers here will combine to give a 9. And I choose the 1 and the 8 because that can give a 9. Since I have a plus sign here, I know that we either are multiplying two positives together or two negatives together. And my clue of what I'm doing is right here. They have to be negatives. You can go ahead and check that, but that is true. That will factor to be that. So the first factor is going to give me x squared is equal to 1. And the second factor is going to give me x squared is equal to 8. I'm running out of room here, so I'm going to come all the way up here. And let's talk about that. So I've got x squared is equal to 1. And I've got x squared is equal to 8. Well, we just solved some equations just like this. When I take the square root, I realize that I'm talking about plus or minus both roots. And when I take the square root over here, I'm talking about plus or minus the square root of 8, which doesn't happen to be a perfect square. But you know what? We've got some tools that we can use to simplify this. The square root of 8 is equal to the square root of 4 times the square root of 2. And that is equal to 2 times the square root of 2. Okay, great. So we've got plus or minus 1 as 2 of the x values, plus or minus 2 square roots of 2 as 2 more. So it looks like we have 4 answers. 4 answers. What I need to do to find the y coordinates, I need to plug these answers into the original thing that I circled right in there. So when I plug in a positive 1, I get 4 divided by 1, which is 4. When I plug in a negative 1, I get 4 divided by negative 1, which is negative 4. So when I plug in a 1, I get a 4. When I plug in a negative 1, I get a negative 4. So those are 2 of my answers. Now I need to plug the plus or minus 2 square root of 2 in right in there. I'm going to circle these answers so I don't forget. Put a box around those. So I'm going to plug in, and I've got 4 divided by 2 square root of 2 as one of them, and 4 divided by negative 2 square root of 2 as the other answer. I don't like these radicals being down in the denominator, so I'm going to rationalize. Actually, I can reduce first. We got 4 over 2, that becomes 2 over 1. And the same sort of thing here, except it's negative, and I'm going to put the negative up top, so negative 2 over the square root of 2. Let's do a quick rationalizing, and then we'll be finished with our answers here. So I'm going to multiply by the square root of 2 over the square root of 2, so I'll have 2 square roots of 2 over 2, which actually we can reduce one more time, and we get square root of 2. So my first y is equal to the square root of 2. When I multiply by the square root of 2 over the square root of 2 here, I get negative 2 square root of 2 over 2, which again can reduce to negative 1 square root of 2. So my other two answers, when I plug in positive 2 square root of 2, I get positive square root of 2 as an output. When I plug in negative 2 square root of 2, negative 2 square root of 2, I get negative square root of 2 as my other answer. So we've got two answers up here, and we've got two answers down here. 4 total answers for this problem. Thank you very much for watching this tutorial. I know this is going to take some practice, and each one kind of is a different little skill to use. And this last one incorporated a bunch of skills: factoring, square root with plus or minus, and we actually had some rationalizing here. So we'll practice this more in class, and a good day to you.